last period we already discussed about the inductive effect. There are two types of inductive effect, minus I effect and plus I effect, and we already discussed about the structural effect on the acid base strength of the compounds. From this, the strength of base is remaining. Now today we will start from the base, that is the basicity of the compound. Now for this we take one example here. Here we compare in between methylamine and ammonia. Now which compound is called as base? Those compounds donate the lone pair of electrons easily is called as strong base or base. Now in this case, this methylamine here CH3 group is plus I group, and it donate the electrons to the nitrogen, and the electron density on this NH2 group is increased. Electron density is increased here, and it donated the lone pair of electrons to H plus very easily as compared to NH3, and hence methylamine is stronger base as compared to ammonia. Now today we will see the next effect is resonance effect. Now resonance effect is the redistribution of electrons operating in unsaturated system via pi bonds and form various canonical structures is called as resonating structures, and the phenomenon is called as, or this effect is called as resonance effect. For explanation, we take the example of benzene. Now here the formula of benzene is, molecular formula is C6H6, and these are the unhybridized 2pz atomic orbitals. Now there are two possibilities of overlapping of these 2pz unhybridized atomic orbitals. Okay. Now suppose we give the numbering for this carbon atom. Now suppose this is unhybridized 2pz atomic orbitals, and there are overlapping of first and 6 2pz atomic orbitals. and we obtain this structure or there are the overlapping in between first and second carbon atom, 2p atomic orbital. Then we obtain, means benzene compound is shown by two structures, first structure and second structure, or we can say that this first structure is converted into second. First structure is converted into second, means this pi bond is shifted from one place to another place and we obtain the second structure. And here these two structures are called as resonance structure. Resonance structure. And suppose we combine these two structures, we obtain the combination of first and second structure, and we can draw by this way. And this is called as resonance hybrid structure. Resonance hybrid structure. We will see the features of this resonance. First one, resonance structure is related to pi bond. Related to pi bond. Second thing is that one form is converted into another form. It is shown by double-headed arrow. Double-headed arrow. And third one, here the combination of different resonating structures is shown by resonance hybrid structure. And this resonating hybrid structure is stable. And fourth one, those chemical species or organic compound shows the more resonating structure, this compound or this chemical species is stable. So these are the some features related to resonance. Now we will see some examples other than benzene. Suppose we consider this resonance in aldehyde, then oxygen is more electronegative and hence pi bond is shifted towards oxygen and here 2 lone pairs. Now here become 3 lone pairs and it carry negative charge and it carry positive charge. Now another example. Butadiene. And one thing is clear here. Resonating structure is shown by, or shifting of electrons is shown by curly arrow. Is shown by curly arrow. And in between the resonating structure we put the double-headed arrow. Now here negative charge and here positive charge. Now we take one example, that is phenoxide ion. When H plus is removed from here, it forms this is phenoxide ion. And we will see the resonating structure of phenoxide ion. Here lone pair is shifted towards phenyl ring. Now here this lone pair is converted into bond pair, and bond pair is converted into charge, is nothing but the lone pair. Now we will continue this one. Finally, so this is original structure we obtain. Original structure. Now on the basis of electron donating or electron withdrawing, groups are attached to carbon skeleton. There are two types of resonance effect. So types of resonance effect. Types of resonance effect. Plus R. Now what happened in this case? Electrons are added in the phenyl ring, and hence this O minus as well as NH2 group or OH. These are the groups under plus R. Means these groups donate the electron to the carbon skeleton. Now another type is minus R. Minus R means the electrons are removed from the carbon skeleton. Removed from the carbon skeleton. The best example is NO2 group, C double bond group. Now here we consider CO. This is the example of minus R effect, and here this is the example of plus R effect. So some groups shows the plus R effect and some groups like NO2 or carbonyl group shows the minus R effect. Now we will see some other examples. Okay, we take the another example, aniline. Aniline, we already consider this NH2 as a plus R effect. Plus R effect. Now why it is called as plus R? Because it increases the electron density of the carbon skeleton. Here benzene phenyl ring. Now see here. Now it acquired positive charge and here negative charge. This lone pair is converted into bond pair. Suppose we change the color of this newly formed bond pair, and this pi bond is converted into lone pair. Now next, resonating structure. Then next one. So this one is original structure. Then we acquired or we obtain original structure. Means these are the resonating structures. These are the resonating structure. and the resonating their hybrid structure is like this way. We can show it carry positive charge and it carry negative charge. This is the resonance hybrid structure. Okay, now we take one example from minus R. The best example is that NO2 group is minus R group and nitrobenzene is the best example of this. Okay, now here due to the 2 oxygen and 1 nitrogen, the bond pair are moved towards the NO2 group, and hence this NO2 group is considered as a minus R group and the effect is called as minus R. Okay, now we will see resonating structures. You know very well about this oxygen carry 2 lone pairs. Here new pi bond, and this oxygen, now this oxygen carry 3 lone pairs. Obviously these carry plus charge. Okay, now here pi bond is shifted towards electron deficient carbon. Here plus charge. Now here we remove here plus charge, and finally we obtain here we obtain original structure. This is original structure, and resonating hybrid structure is right here. here these carry plus charge and these carry minus charge, and this is resonance hybrid structure. Resonance hybrid structure. Now again we take one example from minus R. That is benzaldehyde. Benzaldehyde. C11OH. Benzaldehyde. This is the example of minus R. Now here, due to the oxygen is more electronegative, here O negative, here double bond, and due to the electron deficiency it carry positive charge, and then we move this plus charge in the benzene ring. And lastly, again this pi bond is back toward the electron deficient carbon atom from the phenyl ring. Aromaticity is completed here, and resonating hybrid structure is this having the plus charge, this having the minus charge. Okay, means this example from the minus R group, because electron is removed from the benzene ring, and this benzene ring carry the positive charge and oxygen having the negative charge, and hence this is under the heading minus R. Means the example from plus R and minus R. Example from plus R is oxide ion, then NH2 as well as OH, and from minus R NO2, CHO, etc. Thank you.